Mr. Carlson, the science guy.
Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson, Miss Carlson.
Mr. Carlson, the science guy.
Okay, let's talk about our freezing lab that we've been working with. We started off with you had some cups, and you were mixing the water in the cups with ice, and the purpose there was to reduce the temperature of that solution. Okay, so we're using room temperature water, and we're using ice cubes, which are obviously frozen. Water freezes at 0 degrees Celsius. So if we could put a thermometer on an ice cube, it should read 0 degrees Celsius. So when we mix this ice with water, what happens is the energy in the liquid water is being sent or to the ice. Okay, so the ice is sort of taking some of the energy from the water, and that's why when you mix water and ice, the ice eventually melts, is because the water has energy that it's willing to give up. And so if we were to let water and ice sit for a while, we would get a relatively colder temperature water, but the ice would melt. And so if we were looking at a thermometer, we would probably read 0 degrees Celsius for ice. But what happened in this lab is we started incorporating salt into this situation. And so let's jump to our next slide here. And so salt, what was happening with the salt is very unique. And you have to have the right mixture for this to work. If you have too much water, what happens is there's too much energy in the solution. And so what we want is a small amount of water, because we know that water has energy, and we just want there to be a little bit. Because essentially we want the ice to be doing its job, cooling the whole solution as much as it can. When we incorporate the salt, something really unique happens. So in a regular situation, if we were going to model this using models, these little blue dots here to represent a water molecule, what happens when we freeze is the temperature of the particles, they slow down, right? They reduce, and so their motion slows down, and so they're able to combine together to form an ice molecule. Or it's still a water molecule, but they're forming an ice structure. And so we see this as liquid, pure water, and then when we slow the energy down, it's able to bond and come together to form a solid. So you see that as an ice cube. But the interesting part is when we incorporate salt into this situation, we're going to represent salt here as orange dots. So that would just be table salt. The salt, when we combine it with water, we turn this into salt water. And eventually we'll get this sort of slushy material that's a combination of the water and the ice and the salt together. But the interesting thing here is that the salt blocks the ability for the water to freeze, and that's because it sort of takes up the space, and it takes up the areas where water wants to come together to sort of create this ice structure that you see up here. But the salt blocks that from happening, and so what happens is you're not able to freeze water at 0 degrees Celsius. It's because we've put this material in there, and that material is sort of like saying, no, you cannot come together to form an ice cube. We're gonna block you, sort of, in a way. And so what happens is the ice in that solution is able to chill the water even more. It's able to slow it down even further because it's still essentially a liquid, and that liquid has energy that the ice wants to sort of remove. Energy wants to transfer to the ice to melt it. And so we're able to get what's called this freezing point depression, or a lowered freezing point. And that means that it takes more energy to slow down these particles of water in order to make it freeze or come together. And so you're probably in your thermometer readings, you're probably gonna get you probably should have seen a lower temperature than 0. and you probably still see a slush. You still see water there because that salt is blocking it from becoming an ice. Once it becomes ice, it's 0 degrees, it's frozen. It's not going to get any colder. But if you're able to block the water from becoming ice, you're essentially able to cool it down even more below 0. And so that's what was happening in the freezing experiment. So pretty cool. Noticing just the influence of a little bit of salt can go a long way in terms of what you expect to see.